entity in Jakarta persistence. Now we are focusing on entity. Entities are persistent objects that represent data store records. An entity is a lightweight persistent domain object. Here you can see the life cycle of an entity with respect to the APIs. Here you can see the entity manage operations for managing an entity instances life cycle. An entity instance can be characterized as being new, managed, detached, and removed or removed. New entity instance has no persist identity and is not yet associated with the persistence context. A managed entity instance is an instance with a persistent identity that is currently associated with the persistence context. Detached entity instance is an instance with a persistent identity that is not or no longer associated with the persistent context. A removed entity instance is an instance with a persistent identity associated with the persistence context that will be removed from the database upon transaction commit. Here the use of the cascade annotation element may be used to propagate the effect of an operation to associated entities. The cascade functionality is most typically used in parent-child relationships. Entity instances are created by means of the new operation. An entity instance, when first created by new, is not yet persistent. An instance becomes persistent by means of the entity manager API. Persisting an entity instance, a new entity instance become both managed and persistent by invoking the persist method on it or by cascading the persist operation. Semantics of the persist operation applied to an entity X are as follows. If X is a new entity, it becomes managed. The entity X will be entered into the database at or before transaction commit, or as a result of flush operation. If X is a pre-existing managed entity, it is ignored by the persist operation. However, the persist operation is cascaded to entities referenced by X. if the relationships from X to these other entities are annotated with the cascade equal persist or cascade equal all annotation element value or specified with the equivalent XML descriptor element. If X is a removed entity, it becomes managed. If X is a detached object, the entity exception may be thrown when the persistent operation is invoked, or entity exception or another persistent exception may be thrown at flush or commit time. For all other y referenced by a relationship from X, if the relationships to y has been annotated with the cascade element value cascade equals persist or cascade equal all, the persist operation is applied to y. Removal. A managed entity instance becomes removed by invoking remove method on it or by cascading the remove operation. The semantics of the remove operation applied to an entity X are as follows. If X is a new entity, it is ignored by the remove operation. However, the remove operation is cascaded to entities referenced by X if the relationship from X to other to these other entities are annotated with the cascade equals remove or cascade equals all annotation element value. If X is a managed entity, the remove operation causes it to become removed. The remove operation is cascaded to entities referenced by X if the relationships from X to these other entities are annotated with cascade equal remove or cascade equal all annotation element value. If X is a detached entity, an illegal argument operation illegal argument exception will be thrown by the remove operation, or the transaction commit will fail. If X is a removed entity, it is ignored by the remove operation. A removed entity X will be removed from the database at or before transaction commit. Or as a result of flush operation. After an entity has been removed, its state, except for generated state, will be that of the entity at the point at which the remove operation was called. Detached entities. Detached entity results from transaction commit if a transaction scope persistence context is used from transaction rollback from detaching the entity from persistent context, from clearing the persistent context, from closing an entity manager, or from serializing an entity or otherwise passing an entity by value to a separate application tier through a remote interface, etc. Detached entity instances continue to live outside of the persistence context in which they were persisted or retrieved. They are state is no longer guaranteed to be synchronized with the database state. The application may access the available state of available detached entity instances after the persistence context ends. The available states the available states includes any persistent field or property not marked fetch equals lazy, any persistent field or property that was accessed by the application of fetch by means of an entity graph. If the persistent field or property is an association, the available state of an associated instance may only be safely accessed if the associated instance is available. The available instances include any entity instance retrieved by using find method, any entity instances retrieved by using a query or explicitly requested by in a fetch join, any entity instance for which an instance variable holding non-primary key persistent state was accessed by the application, any instance that can be reached from another variable instance by navigating associations marked fetch equal eager. Here you can see new transient. New transient is new transient interacts with managed. Persist is passed from new transient to manage, and rollback new is passed from manage to new transient. Rollback is an extended persistence context. Manage interacts with new transient, and removed and detached. Refresh is passed from managed to managed. Remove is passed from managed to removed. Persist, rollback passed from removed to managed. Rollback here is an extended persistence context. Commit, rollback clause are passed from managed to detached, and merge is passed from detached to managed. Here detached interact with managed, and removed interacts with managed. Remove is connected to new transient. Commit is passed from removed to new transient. Remove is connected to detached. Rollback is passed from removed to detached. Here you can see entity and relational database table relation. An entity is a persistent domain object. Each entity represents a table in a relational database, and each entity instance corresponds to a row in a table in that table. JP Jakarta persistence uses annotations or XML to map entities to a relational database. The persistent state of an entity fields or properties, setter and getter methods use object relational mapping annotations to map the entities and entity relationships to the data, the relational data in the underlying data store. Here you can see each entity represent a table in a relational database, and each entity instance represent a table row in a relational database. As an example, we can consider annotation type entity. Specified that the class is an entity. This annotation is applied to the entity class. This is in module jakarta.persistence and package jakarta.persistence. As an example 2, we can consider this code segment, creating an employee entity. Here the annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.big-integer. Here the annotation type generated value provides for the specification of generation strategies for the values of primary keys. As an example 3, we can consider this code segment. Mapping of derived identities. Here the dependent entity uses ID class to represent a composite key. The annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.biginteger. The mapped column or for the primary key of the entity is assumed to be the primary key of the primary table. If no column annotation is specified, the primary key column name is assumed to be the name of the primary key property or field. So here the string name matches the name of the ID attribute. Long emp matches the name of the ID attribute and the type of the employee primary key. And here the ID attribute mapped by join column default. As an example 4, we can consider this code segment bidirectional one-to-one relationships. Here the annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can usually be inferred from the type of the object being referred. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here, assuming that entity A here references a single instance of entity B, and entity B references a single instance of entity A. Entity A is specified as the owner of the relationship. The following mapping defaults apply. Entity A is mapped to a table named A, then entity B should map to a table named B. Table A contains a foreign key to table B. The foreign key column name is formed as the concatenation of the following: the name of the relationship property or field of entity A, underscore the name of the primary key column of the table B. The foreign key column has the same type as the primary key of the table B, and there is a unique key constraint on it. Here similarly, entity employee references a single instance of entity cubicle, and entity cubicle references a single instance of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity cubicle is mapped to a table named cubicle. Table employee contains a foreign key to table cubicle. The foreign key column is named assigned cubicle. Underscore primary key of cubicle, where primary key of cubicle denotes the name of the primary key column of the table cubicle. The foreign key column has the same type as the primary key of cubicle. There is a unique key constraint on it. As an example 5, we can consider bidirectional many-to-one and one-to-many relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-knowing one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here annotation type one-to-many specified a many valued association with one-to-many multiplicity. Here entity employee references a single instance of entity department. The entity department references a collection of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply. The entity employee is mapped to a table named employee. The entity department is mapped to a table named department. The table employee contains a foreign key to the table department. The foreign key column is named department underscore primary key of the department, where primary key of the where primary key of the department denotes the name of the primary key column of the table department. The foreign key column has the same type as the primary key department. As an example 6, we can consider unidirectional one-to-one relationships. The annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify associated target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-knowing side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here the entity employee references a single instance of entity travel profile. Entity travel profile does not reference entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. The entity travel profile is mapped to a table named travel profile. The table employee contains a foreign key to table travel profile. The foreign key column is named profile underscore primary key of travel profile, where primary key of the travel profile denotes the name of the primary key column of the table travel profile. Foreign key column has the same type as the primary key of the travel profile, and there is a unique key constraint on it. As an example 7, we are considering unidirectional many-to-one relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, then unowning one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here the entity employee references a single instance of entity address. An entity address does not reference entity employee. Entity employee is the owner of the relationships. The following mapping defaults apply. The entity employee is mapped to a table named employee. Entity address is mapped to a table named address. The table employee contains a foreign key to table address. The foreign key column is the name of the address underscore primary key of address, where the primary key of address denotes the name of the primary key column of the table address. The foreign key column has the same type as the primary key of the address. As an example 8, we can consider this one, the bidirectional many-to-many relationships. The annotation type many-to-many specifies a many valued association with many-to-many multiplicity. Here the entity project references a collection of entity employees. The entity employee references a collection of entity project. The entity project is the owner of the relationship. The entity project is mapped to a table named project. These are the mapping defaults now. The entity employee is mapped to a table named employee. And there's a joint table that is named project underscore employee owner name first. This joint table has two foreign key columns. The one foreign key column refers to the table project and has the same type as the primary key of project. The name of this foreign key column is project primary key of project, where the primary key of project denotes the name of the primary key column of table underscore project. The other foreign key column refers to the table employee and has the same type as the primary key of employee. the name of this foreign key column is employees primary key of employee, where primary key of employee denotes the name of the primary key column of table underscore employee. As an example 9, we can consider this one, unidirectional one-to-many relationships. The annotation type one-to-many specifies many-valued association with one-to-many multiplexity. The entity employee references a collection of entity annual review, and entity annual review does not reference entity employee. Entity employees is the owner of the relationships. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity annual review is mapped to a table named annual review. There's a joint table that is named employee underscore annual review. The owner name first. This joint table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee primary key of employee, where primary key of employee denotes the name of the primary key column table of underscore employee. The other foreign key column refers to the table annual review and has the same type as the primary key of annual review. This foreign key column is named annual reviews primary key of annual review, where primary key annual review denotes the name of the primary key column of table underscore annual review. There is a unique key constraint on the foreign key that refers to annual review. As an example 10, we can consider this one, this code segment, unidirectional many-to-many relationship. Here the annotation type many-to-many specified a many-valued association with many-to-many multiplexity. The entity employee here references a collection of patent. The entity patent does not reference entity employee. Entity employee is the owner of the owner of the relationship. The following mapping defaults apply here. Entity employee is mapped to a table named employee. Entity patent is mapped to a table named patent. There is a joint table that is named employee underscore patent. Owner name first. This joint table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee primary key of employee, where primary key of employee denotes the name of the primary key column of the table underscore employee. The other foreign key column refers to the table patent and has the same type as the primary key of patent. This foreign key column is named patent's primary key of patent, where primary key of patent denotes the name of the primary key column of the table underscore patent. As an example 11, we can consider abstract class as an entity. The annotation type inheritance specifies the inheritance strategy to be used for an entity class hierarchy. it is specified on the entity class, that is the root of the entity class hierarchy. If the inheritance annotation is not specified or no inheritance type is specified for the entity class hierarchy, the single underscore table mapping strategy is used. Here an abstract class can be specified as an entity. An abstract entity differs from a concrete entity only in that it cannot be directly instantiated. An abstract entity is mapped as an entity and can be the target of queries which will operate over and or retrieve instances of its concrete subclasses. Here the annotation type entity specified that the class is an entity, and this annotation is applied to the entity class. Here annotation type table specifies the primary table for the annotated entity. The additional tables must be specified using secondary table or secondary tables annotation. Here the annotation type discriminator value specifies the value of the discriminator column for entities of the given type. Here the annotation type primary key join column specifies the primary key column that is used as a foreign key to join to another table. Here the inherit EMP ID, but the mapped in this class to ft underscore emp dot ft underscore emp id. Inherit version mapped to emp dot version, and inherit address mapped to emp dot address fk. Default to ft underscore emp dot salary here, and here the primary key column is pt underscore emp dot emp id due to primary key join column default. As an example 12, we can consider concrete class as a mapped superclass. The annotation type mapped superclass designate the class whose mapped information is applied to the entities that inherit from it. A mapped superclass has no separate table defined for it. Here the annotation type join column specify the column for joining an entity association or element collection. If the join column annotation itself is defaulted, a single join column is assumed and the default values apply. Here the annotation type association override is used to override the mapping of for an entity relationship. Here name is required and the name of the relationship property whose mapping is being overridden if the property based access is being used, or the name of the relationship field if field based access is used. Here join columns, the join columns being mapped to the persistent attributes. Here the default table is here emp ft employee, and here the inherited emp id field mapped to ft ft employee dot emp id. Here the inheritance version field mapped to ft employee dot version. Here the inheritance address field mapped to ft employee dot addr fk, and the defaults to ft employee dot salary. Here here the inheritant emp field mapped to pt underscore emp dot emp id. Here inheritance field is mapped to pt underscore emp dot version, and here address field is mapping address field mapping overridden to pt underscore emp dot addr underscore id fk. As an example 13, we can consider this code segment non-entity superclass. An entity can have non-entity superclass which may be either concrete or abstract class. And here operation count is in transient state. As an example 14, we can consider naming of database objects. Here the annotation type table specifies the primary table for the annotated entity. Additional tables may be specified using secondary table or secondary tables annotations. Now we are considering entity class, the entity class in entities. The entity class must be annotated with an entity annotation or denoted in the XML descriptor as an entity. The annotation type entity in package Jakarta.persistence in module Jakarta.persistence specified that the class is an entity and this annotation is applied to the entity class. The entity class must be annotated with the entity annotation or denoted in the XML descriptor as an entity. The entity class must have a no-arg constructor. The entity class may have other constructors as well. The no-arg constructor must be public or protected. The entity class must be a top-level class, and enum or interface must not be designated as an entity. Entity class must entity class must be top-level class. Enum or interface must not be designated as an entity. Entity class must not be final. No method or persistent instance variable of the entity class may be final. An entity, if an entity instance is to be passed by the value as detached object, for example through a remote interface, the entity class must implement the serializable interface. Entity support inheritance. Entities support inheritance, polymorphic associations, and polymorphic queries. Both abstract and concrete classes can be entities. Entities may extend non-entity classes as well as entity classes, and non-entity classes may extend entity classes. The persistent state of an entity is represented by instance variables, which may correspond to Java Beans properties. An instance variable must be directly accessed only from within the method of an entity by the entity instance itself. Instance variables must not be accessed by the client of the entity. The state of the entity is available to the client only through the entity's methods, that is accessor methods, getter or setter methods, or other business methods. Here you can see, here we are considering persistent fields and properties. You can see the example here. No arc constructor, property accessed is used. Business methods to add phone number to the customer. Update the phone entity instance to refer to this customer. Now we are considering default access type. In access type, the access type is explicitly specified by means of the access annotation. The annotation type access in package Jakarta to persistent in module Jakarta to persistence used to specify an access type to be applied to an entity class, mapped superclass to embeddable class, or to the specific attribute of such a class. By default, the single access type field or property access applies to an entity hierarchy. The default access type of an entity hierarchy is determined by the placement of mapping annotation on the attributes of the entity classes and mapped superclasses of the entity hierarchy that do not explicitly specify the access type. The access type is explicitly specified by the means of access annotation. When annotations are used to define the default access type, the placement of the mapping annotations on either of persistent field or persistent properties of the entity class specify the access type as being either field or property based access respectively. When the field-based access is used, the object relational mapping annotations for the entity class annotate the instance variable, and the persistent provider runtime access the instance variable directly. All non-transient variable instance variables that are not annotated with the transient annotations are persistent. When the property-based access is used, the object relational mapping annotations for the entity class annotate the getter property accesses, and the persistent provider runtime access persistent state via the property accessor methods. All properties not annotated with the transient annotation are persistent. Mapping annotations must not be applied to the field or properties that are transient or transient. All such classes in the entity hierarchy whose access type is defaulted in this way must be consistent in their placement of annotations on either field or properties such that single consistent default access type applied within the hierarchy. Any embeddable classes used by such classes will have the same access type as the default access type of the hierarchy unless access annotation is specified as defined below. If it is an error if the default access type cannot be determined and access type is not explicitly specified by means of annotations or the XML descriptor. The behavior of the applications that mix the placement of annotation on fields and properties within the entity hierarchy without explicitly specifying the access annotation is undefined. Now we are considering primary keys corresponding to derived identities. Examples of derived identities in primary keys and entity identity. Dependent entity uses ID class to represent a composite key. The annotation type ID class in package Jakarta.persistent in module Jakarta.persistent. They specify the composite primary key class that is mapped to the multiple fields or properties of the entity. The identity of an entity may be derived from the identity of the another entity, the parent entity. When the form entity, the dependent entity, is the owner of the many-to-one or one-to-many relationships to the parent entity. And the foreign key maps the relationship from dependent entity. If many-to-one or one-to-many relationship correspond to the primary key attributes, the entity contained in this relationship cannot be persisted without the relationship having been assigned to entity, since the identity of the entity contained in the relationship is derived from the reference identity. Reference entity. Derived entities. The derived identities may be captured by means of simple primary keys, so by means of composite keys. If the dependent entity class has the primary key attributes in addition to the those correspond to the parent's primary key, or if the parent has the composite key and the embedded ID or ID class must be used to specify the primary key of the dependent entity. It is not necessary that parent entity and the dependent entity both use the embedded IDs or both use the ID classes to represent composite primary keys when parent has composite key. A dependent entity may have more than one parent entity. Here you can see the examples of derived identities. The parent entity has a simple primary key here. The case the dependent entity uses ID class to represent the composite key. This is the sample query. Matches the name of the at ID attribute. Matches the name of that ID attribute and the type of the employee PK. ID attributes mapped by join column default. Now we are considering basic type. Basic type is any Java primitive type, wrap of the primary types, Java wrap of the primitive types, java.long.string, java.math.biginteger, java.math.bigdecimal, java.util.date, java.util.calendar, java.util.sql.date, java.sql.time, java.sql.timestamp, java.time.local.date, java.time.local time, java.time.local.date time, java.time.offset time, java.time.offset date time, byte array, character array, enum, any other type that implements serializable. Now we are considering embeddable classes. An entity may have collections of embeddables as well as single valued embeddable attributes. The annotation type embeddable in package Jakarta.persistent in module Jakarta.persistence. Specify the class whose instances are stored as an instance part of an owning entity as a share the identity of the entity. Each of the persistent properties or field of the embedded object is mapped to the database table for the entity. An entity may use other fine-grained classes to represent entity state. Instances of these classes, unlike entity instances, do not have persistent identity of their own. Instead, they exist only as part of the state of the entity to which they belong. An entity may have collections of embeddables as well as single-valued embeddable attributes. Embeddables may also be used as map key and maps values. Embedded objects belong strictly to their owning entity and are not shareable across persistent entities. Attempting to share an embedded object across entities has undefined semantics. Embeddable classes must adhere to the requirement specified in the specification for entities, with the exception that embeddable classes are not annotated as entity. Embeddable classes must be annotated as embeddable or denoted in XML script as such. Embeddable class may be used to represent a state of another embeddable class. The embeddable class, including an embeddable class within another embeddable class, may contain a collection of basic type or other embeddable class. An embeddable class may contain a relationship to any entity or collection of entities. Since the instances of embeddable classes themselves have no persistent identity, the relationship from the reference entity is to entity that contain embeddable instances are not to the embeddable itself. The embeddable class that is used as an embedded ID or as a mapped key must not contain such a relationship. Additional requirements and restrictions on embedded classes are described in the documentation. Now we are considering collections of embeddable classes and basic types. Such a collection, when specified, such as by the element collection annotation, is mapped by the means of a collection table. The annotation type element collection in package Jakarta.persistence in module Jakarta.persistence specifies a collection of instances of a basic type or embeddable class must be specified if the collection is to be mapped by means of a collection table. A persistent field or property of an entity or embeddable class may correspond to a collection of basic type or embeddable class element collection. Such a collection, when specified as such by the element collection annotation, is mapped by the means of collection table. If the element collection annotation or XML equivalent is not specified for the collection value field property, the rules in the documentation apply. That embeddable class, including an embeddable class within another embeddable class that is contained within the element collection, must not contain an element collection, nor may it contain relationship to other relationship to an entity other than many one-to-one or many-to-one or one-to-one relationship. The embeddable class must be on the owning side of such a relationship, and relationship must be mapped by the following key mapping. Now we are considering map keys in map collections. If a map key type is a basic type, the map key column annotation can be used to specify the column mapping for the primary key. The annotation type map key column in package Jakarta.persistence in module Jakarta.persistence specify the mapping for the key column of the map whose map key is the basic type. The name element is not specified. It defaults to the concatenation of the following: the name of the referencing relationship field or property, underscore key or semicolon key. If the map key type is basic type, the map key column annotation can be used to specify the column mapping for the map key. If the map key column annotation is not specified, the default values of the map key column annotation apply. If the map key type is embeddable class, the mapping for the map key columns are default defaulted according to the default column mappings for the embeddable class. The attribute override and attribute overrides annotation can be used to override these mappings. If an embeddable class is used as a map key, the embeddable class must implement the hash code and equals method consistently with the database columns to which the embeddable is mapped. If the map key type is an entity, map key join column and map key join columns annotations are used to specify the column mapping for the map key. If the primary key of the reference entity is a simple primary key and the map key join column annotation is not specified, the default values for the map key join column annotation apply. If a Java generic types are not used in the declaration of relationship attributes of type java.util.map, the map key class annotation must be used to specify the type of the key of the map. The map key annotation is used to specify the special case where the map key is itself a primary key and persistent field or property of the map key of the entity, that is the value of the map. The map key class annotation is not used when the map key is specified. Now we are considering mapping defaults for non-relationship fields or properties. If the type is a class that is annotated with the embeddable annotation, it is mapped in the same way as if the field or property were annotated with an embedded annotation. The annotation type embeddable in package Jakarta.persistent in module Jakarta.persistence specify a class whose instances are stored as an intrinsic part of the owning entity and share the entity of the entity. Each of the persistent properties or field embedded of the embedded object is mapped to the database table for the identity. If a persistent field or property other than the relationship property is not annotated with one of the mapping annotations, or equivalent mapping information is not specified in the XML descriptor, the following default mapping rules are applied in order. If the type is a class that is annotated with embeddable annotation, it is mapped to the same way as if field or property were annotated with the embedded annotation. If the type of the field or property is one of the following, it is mapped in the same way as it would if it is annotated as basic. Java primitive types, wrappers of the primitive types: java.line.string, java.math.biginteger, java.math.big decimal, java.util.uuid, java.util.date, java.util.calendar, java.sql.date, java.sql.time, java.sql.timestamp, java.time.localDate, java.time.localTime, java.time.localDateTime, java.time.offsetTime, java.time.offsetDateTime, byte array, char array, character array, enums, and any other type that implements serializable. It is an error if no annotation is present and none of above rules apply. Now we are considering entity relationships. If there is an association between two entities, one of the following relationship modeling annotations must be applied to the corresponding persistent property or field of the reference entity: one-to-one, one-to-many, many-to-one, and many-to-many. Annotation type one-to-one in package Jakarta.persistent in module Jakarta.persistent specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can usually be informed from the type of the object being referenced. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Annotation type one-to-many in package Jakarta.persistence in module Jakarta.persistence specifies a menu valued association with one-to-many multiplicity. Annotation type many-to-one in package Jakarta.persistent in module Jakarta.persistence specified single valued association to another entities that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-owning one-to-many entity side must be used in the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Annotation type many-to-many in package Jakarta.persistence, in module Jakarta.persistence specify a many valued association with many-to-many. Relationship among entities may be one-to-one, one-to-many, many-to-one, and many-to-many. Many-to-many relationships are polymorphic. If there is an association between two entities, one of the following relationship modeling annotations must be applied to the corresponding persistent property or field of the referencing entity: one-to-one, one-to-many, many-to-one, and many-to-many. For the association that do not specify the target type, for example, where generic types are not used for collections, it is necessary to specify an entity that is target of the relationships. Equivalent XML element may be used as an alternative to these annotations. These annotations mirror common practice in relational database schema modeling. The use of relationship modeling annotation allows the object relational mapping of the association of relational database schema or fully defaulted to provide ease of development facility. A relationship may be bidirectional or unidirectional. Bidirectional relationship has both an owning side and the inverse non-owning side. The unidirectional relationship has only an owning side. Owning side of the relationship determines the updates to relationship in the database. Following rules apply to bidirectional relationships. The inverse side of the bidirectional relationship must refer to its owning side by using the mapped by element of one-to-one, one-to-many, or many-to-many annotation. Mapped by element designate the property or field in the entity that is the owner of the relationship. The many side of the one-to-many or many-to-one bidirectional relationship must be the owning side. Hence, the mapped by element cannot be specified in many-to-one annotation. For one-to-one bidirectional relationships, the owning side corresponds to the side contain the corresponding foreign key. The many-to-many bidirectional relationships, either side may be the owning side. Relationship modeling annotation constrains the use of cascade equal remove specification. The cascade is equal remove specification should only be applied to the association that are specified by one-to-one or one-to-many. One-to-many applications that apply cascade equal remove to other associations are not portable. Associations that specified as one-to-one or one-to-many support support of an orphan removal option. Following behaviors apply when orphan removal is in effect. An entity that is the target of the relationship is removed from the relationship by setting the relationship to null or removing the entity from the relationship connection. The remove operation will be applied to the entity being orphaned. The remove operation is applied at the time of flush operation. The orphan removal functionality is intended for the entities that privately owned by the parent entity. Portable applications must override but otherwise not depend upon such order of removal and must not reassign an entity that has been orphaned to another relationship or otherwise attempt to persist it. If an entity being orphaned is detached, new, or removed entity, the semantics of orphan removal do not apply. If the operation remove option, if the remove option is applied to the managed source entity, the remove operation will be cascaded to the relationship target of the accordance with the rules. And hence it is not necessary to specify cascade equal remove for the relationships. Additional mapping annotations, for example, column and table mapping annotations may be specified to override or further refine the default mappings and mapping strategies. In addition, This specification also requires support for following alternative mapping strategies. Mapping of the unidirectional one-to-many relationships by means of foreign key mappings. Joint column annotation or corresponding XML element must be used to specify such non-default mappings. Mapping of unidirectional and bidirectional one-to-one relationships, bidirectional many-to-one or one-to-many relationships, and unidirectional many-to-one relationships by means of joint table mappings. Joint table annotations or corresponding XML element must be used to specify the non-default mappings. Such mapping annotations must be specified on owning the side of the relationships. Any overriding of mapping defaults must be consistent with the relationship modeling annotation that is specified. For example, if a many-to-one relationship is many-to-one relationship mapping is specified, it is not permitted to specify unique key constraint on the foreign key for the relationship. The persistent provider handles the object relational mapping of the relationships, including their loading and storing to the database as specified in the metadata of the entity class, and the referential integrity of the relationship as specified in the database by foreign key constraint. Note that it is the application that bears the responsibility for maintaining the consistency of runtime relationships. For example, for inserting that one and the many sides of the bidirectional relationships are consistent with one another when application updates the relationship at runtime. If there are no associated entities for multi-valued relationship of an entity fetched from the database, the persistent provider is responsible for returning the empty collection as the value of the relationship. Now we are considering bidirectional one-to-one mappings in relationship mapping defaults. This is an example. Annotation type one-to-one in package Jakarta.persistent and in module Jakarta.persistence specified a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can be usually inferred from the type of the object being referenced. If the relationship is bidirectional, non-owning side must be the mapped. You must use the mapped by element of the mapped by element of the one-to-one annotation to specify the relation field or property. Now we are considering here assuming that entity A references the single instance of entity B, and entity B references a single instance of entity A. A is specified as the owner of the relationship. The following mapping defaults apply. Entity A mapped to the table named A. Entity B mapped to the table named B. Entity A contains the foreign key to the table B. Foreign key column name is formed as a concatenation of the following: name of the relationship property or field of an entity A, underscore the name of the primary key of the column and name of the entity B. The foreign key column has the same type of the primary key of the table B. There is a unique key constraint on it. In this example, entity employee references a single instance of the entity cubicle. Entity cubicle references a single instance of entity employee. Entity employee is the owner of the relationship. Following mappings defaults apply. Entity employee is mapped to the table named employee. entity cubicle is mapped to a table name cubicle. Table employee contains a foreign key to the table cubicle. The foreign key column is named assign cubicle underscore pk of cubicle, where pk cubicle denotes the name of the primary key. Of the table cubicle. The foreign key column has the same type of the primary key of the cubicle, and there is a unique key constant on it. Now we are considering abstract key entities in inheritance. Example here, abstract class as an entity. Module annotation type inheritance in package Jakarta.persistent in module Jakarta.persistence specify the intended strategy to be used for an entity class hierarchy. It is specified on the entity class that is the root of the entity class hierarchy. If the inheritance annotation is not specified or no inheritance type is specified for an entity class hierarchy, a single table mapping strategy is used. An abstract class can be specified as an entity. An abstract entity differs from the concrete entity only in that it cannot be directly instantiated. An abstract entity is mapped as an entity that can be the target queries which will operate over and or retrieve instances of its concrete subclasses. An abstract entity class is annotated with the entity annotation or denoted in the XML descriptor as an entity. The following example shows the use of abstract entity class in the entity inheritance hierarchy. Inherit emp id but mapped in this class to ft underscore empt.eft emp id. Inherit version mapped to the emp.version. Inherit version mapped to the emp.address fk. Default to ft underscore emp.salary. pk column is pt underscore emp.empid due to the primary underscore primary key column, primary key joint column underscore default. Single table per class hierarchy strategy in inheritance mapping strategies. In this strategy, all the classes in the hierarchy are mapped to a single table. In an inheritance type, the public static final inheritance type table per class, a table per concrete entity class. In enum inheritance type, in package Jakarta.persistent, in module Jakarta.persistence. In this strategy, the all classes in the hierarchy are mapped to a single table. The table has column that serves the discriminator column, that is a column whose value identifies the specific subclass to which the instance that is represented by the row belongs. This mapping strategy provides good support for the polymorphic relationship between entities and for queries that range over the class hierarchy. It has the drawback, however, it requires that the column that correspond to the specific correspond to state specific to the subclass be nullable. Now we are considering naming of database object. For example, assuming the use of English local, the following must be passed to the database as unlimited identifiers, so that they will be treated as equivalent for all databases that comply with the SQL standard requirement for the treatment of regular identities, undelimited identifiers, and delimited identifiers. The annotation type table in package Jakarta persistent in module Jakarta persistent specify the primary table for the annotated identity. Additional tables may be specified using secondary table or secondary table annotations. The many annotation and annotation elements contain names of the database objects. I have assumed default names for the database objects. This is in this specification requires the following regard to be the interpretation of the names reference to the database object. These names include names of the tables, columns, and other database elements. Such names also include names that result from defaulting. For example, a table name that is defaulted from an entity name, or column name that is defaulted from field or property. By default, the names of the database object must be treated as undelimited identifiers and passed to the database as such. For example, assuming the use of English local, the following must be passed to the database as undelimited identifiers, so that they will be treated as equivalent for all databases that comply with the SQL standards requirement for treatment of regular identified, unlimited identified, and delimited identifiers. Similarly, the following must be treated as equivalent. To specify delimited identifiers, one of the following approaches must be used. It is possible to specify that all database identifiers in use for persistent unit be treated as delimited identifier by specifying the delimited identifiers element within the persistent unit default element of the object relational XML mapping file. If the delimited identifier element is specified, it cannot be overridden. It is possible to specify on per name basis that a name for a database object is to be interpreted as delimited identifier as follows using annotations. A name is specified as delimited identifier by the enclosing the name within double quotes, whereby the inner quotes are escaped. For example, you can use the table, the name, here the backslash, then double quotation, and again backslash double quotation here. When using XML, a name is specified as delimited identifier by using double quotes. For example, table name equal double quotation, ampersand quote, semicolon, customer, then ampersand quote, semicolon, double quotation. Now we are considering entity instance creation in entity instances lifecycle in entity operations. Entity instances are created by means of new operation. The entity instance are created by means of new operation, and the entity instance, when it's first created by new is not yet persistent. The instance become persistent by means of entity manager API. Now we are considering pessimistic locking in pessimistic locking. The values of the Jakarta persistent.lock.scope property is defined by the pessimistic lock scope enum. Pessimistic lock enum pessimistic lock scope in package Jakarta persistent in module Jakarta persistence define the values of the Jakarta persistent lock.scope property for pessimistic locking. This property may be passed as an argument to the method of the entity manager, query, and type query interface that allow lock mode for specified or used with a named query annotation. While optimistic locking is typically appropriate in dealing with moderate contention among concurrent transactions. In some application, it may be useful to immediately obtain long-term database locked for selected entities because the often late failure of optimistic operations, such as immediately obtaining long-term database locked, are referenced as pessimistic lock. Pessimistic locking guarantees that once a transaction has obtained a pessimistic lock on an entity instance, no other transaction, whether transaction of an application using Jakarta Persistent API or any other transaction using underlying resource, may be successfully modify or delete that instance until the transaction holding lock is ended. If the pessimistic lock is an exclusive lock, the same transaction may modify or delete that entity instance. When an entity instance is locked using pessimistic locking, the persistent provider must lock the database row that correspond to non-collection valued persistent state of that instance. If a joint inheritance strategy is used, or if the entity is otherwise mapped to a secondary table, this entails locking the rows for entity instance in the additional tables. Entity relationship for which the locked entity contains the foreign key will also be locked, but not the state of the reference entities unless those entities are explicitly locked. Element collections are relationships for which the entity does not contain the foreign key. Such relationships that are mapped to the joint tables or directional one-to-many relationships for which the target entity contains the foreign key will not be locked by default. Element collections are relationships owned by the entity that contain a joint table will be locked if the Jakarta.persist.lock.scope property is specified with the value of pessimistic locked scope extended. The state of entities referenced by such entities will not be locked unless the entities are explicitly locked. This property may be passed as an argument to the method of the entity manager query or type query interfaces that allow lock modes to be specified or used with the named query annotation. Locking such relationship or element collection generally locked only the rows of the joint table or collection table for the relationship collection. This means that phantoms will be possible. The values of Jakarta.persistent.lock.scope property are defined by pessimistic lock property enum, pessimistic lock scope enum. This specification does not define the mechanism of a persistent provider that uses the obtained database locked, and portable application should not try how pessimistic locking is achieved on database. In particular, persistent provider or underlying database management system may lock more rows than one selected by the application. Whenever a pessimistically locked entity containing a version attribute is updated on the database, the persistent provider must also update the increment the entity version column to enable the correct interaction with the application using optimistic locking. Pessimistic locking may be applied to entities that do not contain version attributes. However, in this case, correct interaction with application using optimistic locking cannot be ensured. Now we are considering entity listeners and callbacks, and in this an example and annotation type entity listeners in package Jakarta persistent in module Jakarta persistence. We specified the callback listener classes to be used as an entity or mapped superclass. This annotation may be applied to an entity class or mapped superclass. The semantics of the lifecycle callbacks methods of entities, the pre-persist and pre-removed callbacks methods are invoked for given entity before respective entity manager persist or remove operation for that entity executed. For entities which merge operations has been applied and causes creation of newly managed instance, the pre-persist callback methods will be invoked for the managed instances after the entity state has been copied to it. These pre-persist and pre-remove callbacks will also be invoked on all entities to which the operations are cascaded. Pre-persist and pre-remove methods will always invoked as part of the synchronous persist, merge and remove operations. The post persist or post remove callback method will invoke for the entity after the entity has been made persistent or removed. These callbacks will be also be invoked in all entities to which these operations are cascaded. Post persist and post remove methods will be invoked after database insert or delete operation respectively. Those database operations may occur directly after the persist, merge or remove operations have been invoked, or they occur directly after flush operation has occurred, which may be at the end of the transaction. Generated primary key values are available in the post persist method. Pre-update and post-update callbacks occur before and after database update operations to entirely read data respectively. That these database operations may occur at the time the entity state is updated, or may occur at the time the state is flushed to the database, which may be at the end of the transaction. Note that it is implementation dependent as to whether pre-update or post-update callbacks occur when entities persisted and subsequently modified in a single transaction, or when an entity is modified and subsequently removed within a single transaction. Portable applications should not rely on such behavior. Post-load method for an entity is invoked after entity has been loaded into the current persistent context from the database, so refresh operation has been applied to it. Post-load method is invoked before a query result is returned or accessed before an association is traversed. It is implementation dependent as to whether callbacks method are invoked before or after cascading the lifecycle event is to related entities. Application should not depend on this ordering. Because status depend upon the non-transient context. Now we are considering enabling automatic validation in automatic validation upon lifecycle in bean validation. The validation mode element of the persist.xml determines whether the automatic lifecycle event validation is in effect. The values of the validation mode element are auto, callback, none. The default value validation mode is auto. If the application creates an entity manager factory using the persist.create entity manager factory method, the validation mode can be specified by using jakarta.persist.validation.mode map key, which will override the default or the value is specified on the or defaulted on the persist.xml. The map values for this keys are auto, callback, and none. If the auto validation mode is specified by the validation mode element or the jakarta.persist.validation.mode property, or if neither the validation mode element nor the jakarta.persist.validation.mode property is specified, the bean validation provider is present in the environment. The persistent provider must perform the automatic validation entities or validation of entities. If the no bean validation provider is present in the environment, no lifecycle event validation takes place. If the callback validation mode is specified by the validation mode element and or the jakarta.persist.validation.mode property, the persistent provider must perform the lifecycle event validation. It is an error if there is no bean validation provider present in the environment, and the provider must throw the persistent exception. If the jakarta.persist.validation.mode property value callback has been passed to the persistent.create entity manager factory method. If non-validation mode is specified by the validation mode element or jakarta.persist.validation.mode property, the persistent provider must not perform lifecycle event validation. Now we are considering fetch graph examples in fetch graph semantics, use of entity graphs to find query operations in entity graphs. The annotation type name entity graph in package jakarta.persistent in module jakarta.persistence used to specify the path and boundaries for find operation or query. The examples in here, the only number attributes would be eagerly fetch. In this example here, the employee entity's primary key will be fetched, as well as related project instances. Whose default fetch graph ID, name, and doc attributes. Will be fetched. Related requirements object will be fetched according to its default fetch graph. If the approver attributes large project were fetch type eager, and if the any of the projects were instances of large project, the approver attributes would also be fetched. Since the approver attribute is employee, since the type of the approver attributes its employee, the approver default fetch graph ID, name, and employee number attributes would be fetched. Now we are considering type conversion of basic attributes. If the value of the auto-apply element of the converter annotation is true, the converter will be applied to all attributes of the target type, including the basic attributes values that are combined within other more complex attributes. The interface attribute converter in package Jakarta.persistent in module Jakarta.persistence. Class that implements this interface can be used to convert entity attribute state into database column representation and back again. Note that X and Y types may be the same Java type. The attribute conversion facility allows the developer to specify a method to convert between entity attributes representation and the database representation for attribute basic types. Converters can be used to convert basic attributes defined by entity classes, map superclasses, and embeddable classes. An attribute converter must implement the Jakarta persistent attribute convert interface. A convert implementation class must be annotated with the convert annotation or defined in XML descriptor as a converter. The value of the auto apply element of the convert annotation is true. If the value of the auto apply element of the convert annotation is true, the converter will be applied to attributes of the target type, including basic attributes that contain within other more complex attribute types. Attribute converter classes in Jakarta environment support dependency injection through the context and dependency injection API CDI when CDI is enabled. Attribute converter class that makes use the CDI injection may also define lifecycle callbacks method annotated with the post contract and pre-destroy annotations. This method will be invoked after the injection has taken place and before attribute converter instances are destroyed respectively. Persistent provider is responsible for creating CDI SPI to create instances of attribute converter class to perform injection upon such instances, to invoke their post contract and pre-destroy method if any, to dispose of the attribute converter instances. Persistent provider is only required to support CDI injection into attribute converters in Jakarta content environment. If CDI is not enabled, the persistent provider must not invoke the attribute converters that depend on CDI injection. Now we are considering shared caching mode element in caching. Whether the entities and entity-related state of persistent unit will be cached is determined by the value of the shared cache mode element of the persistent.xml file. The shared cache mode element has 5 possible values: all, none, enable, selective, disable selective, and unspecified. The value of all clauses, all entities, all causes, all entities and entity-related state and data to be cached. The value of non-causes caching to be disabled for persistent unit. Persistent providers must not cache if none is specified. The values of enable selective and disable selective are used to use conjunction with cacheable annotation or XML element. The cacheable annotation is specified whether an entity should be cached if such selective caching is enabled by the persistent.xml shared cache mode element. Cacheable element is specified on the entity class. It applies to a given entity and its subclasses unless subsequently overwritten by the subclass. Cacheable false mean that entity and its state must not be cached by the provider. Value enable selective enable the cache and causes entities for which cacheable true or its XML equivalent is specified to be cached. Entities for which cacheable true is not specified or for which cacheable false is specified must not be cached. The value disable selective enable the cache and causes all entries to be cached except for those cacheable false is specified. Entities for cacheable false is specified must not be cached. If either shared cache mode element is not specified in the persistent.xml file or the value of the shared cache mode element unspecified and the Jakarta.persistent.shared cache .mode property is not specified, the behavior is not defined. The property provider specific default may apply. If the shared cache mode element in the Jakarta.persistent.shared cache .mode property are not specified, the semantic cacheable annotation and XML equivalent are undefined. Persistent provider is not required to support the use of second level cache. If the persistent provider does not support the use of the second level cache or second level cache is not installed, this element will be ignored and no caching will occur. Now we are considering cache retrieve mode and cache store mode properties. The cache retrieve mode property is the ignored for refresh method and always causes data to be retrieved from the database, not caches. Not the cache enum cache retrieve mode in package Jakarta persistent in module Jakarta persistent used as the value of the Jakarta persistent.cache to retrieve mode property to specify the behavior when data is retrieved by the find method or by queries. Enum cache mode is cache store mode in package Jakarta persistent in module Jakarta persistence used as the value for the Jakarta persistent cache store mode property to specify the behavior when data is read from the database and when data is committed to the database. Cache retrieve mode and cache store mode properties may be specified at the level of persistent context by means of the entity manager set property method. These properties may be specified for the entity manager find and refresh method and query type query and store procedure query set hint method. Cache retrieve mode and cache or cache store mode properties specified for the find, refresh and query and type query and store procedure query set hint method. Override those specified and persistent context for the specified find and refresh invocation for the execution of the specified query specifically. If caching is disabled by none, the values of the shared cache mode element, cache retrieve mode and cache store mode properties must be ignored. Otherwise, the enable selective value is specified. The cacheable true is not specified for the particular entity. They are ignored for that entity and disable. If the disable selective value is specified, they are ignored by entities with the cacheable false is specified. Cache retrieve mode and cache store mode properties must be observed when the caching is enabled. regardless of whether caching is enabled due to the specification of shared cache mode element or enabled due to the provider specific options. Applications that make use of the cache retrieve mode or cache store mode properties but which do not specify the shared cache mode element will not be portable. Cache retrieve mode and cache store mode properties are Jakarta.cache.retrieve mode and Jakarta.cache store mode. Respectively, these properties have semantics and cache retrieve mode properties specify the behavior when data is retrieved by the find methods and by execution of queries, and the cache retrieve mode property is ignored for the refresh method, then always causes data to be retrieved from the database, not the cache. Data store mode properties specify the behavior when data is read from the database and when it is committed to the database. Now we are considering entity type expressions and scale expression in conditional expression in query language. These are the you can see the examples. An entity type expression can be used to restrict query polymorphism. The type operator returns the exact type of the argument. The syntax of the type expression is as follows. The entity type literal is designated by the entity name. The Java class of the entity is used as an input parameter to specify the entity type. Now we are considering entity type interface in MetaModel API. Interface entity type type parameter x in package Jakarta.persist.metamodel in model Jakarta.persistence. Instances of the type entity model represent entity types. Now we are considering entity in metadata annotation. This name is used to refer the entity queries. The annotation type entity in package Jakarta.persistence in module Jakarta.persistence specifies that the class is an entity. This annotation is applied to the entity class. Entity annotation is specified that the class is an entity. This annotation is applied to an entity class. The name annotation element is specified the entity name. If the name element is not specified, the entity name default to the unqualified name of the entity class. This name is used to refer to the entity in queries. Now we are considering named entity graph and named entity graphs annotations. In entity graph annotations, the named entity graph annotation can be used to specify multiple named entity graphs for the entity to which it applied. The annotation type named entity graph in package Jakarta.persistence in module Jakarta.persistence used to specify the path and boundaries for the find operation or query. Annotation type named entity graphs in package Jakarta.persistence in module Jakarta.persistence used to group named entity graph annotations. Now we are considering NTA listeners in persistent with default sub-element in XML overriding rules in XML object relational mapping descriptor. The entity listener sub-element define default entity listeners for the persistent unit. These entity listeners are called before any other entity listeners for an entity unless the entity listener order is overridden with the mapped superclass to entity element, or the exclude default listener annotation is present on the entity or map superclass, so the exclude default listener sub element is specified within the corresponding entity or map superclass XML element. Now we are considering other sub-element of the entity mappings element, entity. The entity sub-element define an entity of the persistent unit. It is undefined if multiple mappings files of the persistent unit contain entities for the same entity. The entity class may or may not be may or may not have been annotated as entity. The entity sub-element and attributes of entity element overrides. The name entity graph in entity sub-elements and attributes. The name entity graph while sub-element is additive to any named entity graph annotation on the entity. It overrides any entity graph annotation with the same name. As an exception example, we can consider class entity not found exception thrown by the persistence provider when an entity reference obtained by entity manager.get reference is accessed but the entity does not exist. Thrown when entity manager.refresh is called and the object no longer exists in the database. Thrown when entity manager.lock is used with the pessimistic locking is used and the entity no longer exists in the database using the package Jakarta.persistence and the module Jakarta.persistence.